Hello everyone and welcome back to another video. In this video, we'll be speaking of consistent hashing. But before we speak of what consistent hashing really is, we should ask why do we even need hashing, right? So just we will understand it with a very simple example. That is, just imagine you have a client sending a request to server and you are basically querying the database for results, or you are storing data into the database. Now this all sounds really good and really fine when you are dealing with small scale of data. So what happens when there is large scale of data, right? Like there is more data incoming, and storing everything in one single server just increases the load and it induces the problem of single point of failure. So the next valid step would be to increase the number of databases, right? So you scale the system and you introduce like more databases, right? So you have here three databases. So now any request coming could be routed to any of these databases. So that should solve the problem, right? But this creates another big problem, that is, where should we route the data to? If input request is coming, on which database should I even be storing the result is the question, because storing in one single database could leave the other two databases idle, and this database could alone get very overwhelmed. We don't want that. Now let us introduce hashing here, which solves this problem. So hashing is nothing but a function. Okay, it takes an input and it gives a unique output which is always consistent, which means for one input it always gives the same output, which means it is deterministic. So in this case, how will this function will be useful? Let's understand that. So client sends a request ID. Let's take 1234 for an example, and we have a function which converts this input into a fixed range of output, right? It gives a number, and let's say it gives a random number. Let's say it gives 67211. So now what we can do is we can use this formula which is hash of request ID, and we do modulo of n, and here n is nothing but the databases, like the number of servers or databases. So here it is 3, so we have 3 here. So what we basically do is we take modulo of 67211 and with the n value, and we get 2 as the output. Now this is used for routing the requests. What do I mean by that is, we will send this request, we will store it in this db2 is what I mean. So now why are we doing it? It solves one of the major problems, that is, it helps us to evenly distribute the load. That is, with this we can randomly assign and evenly distribute the load so that no one single database gets very much overwhelmed. So here we can just understand what hash functions solves the problem, right? Like, also let us say that we have a request and you store it in, let's say, db2, and what happens in the next time the user gives the same input. How do you find that this request was stored in db2? Manual scanning to each and every database is very costly, because let's say you scan for db1 and check for that information, and then you check for like db2, and it goes on, right? Like, this is not feasible. So that is why hash functions give this key value pair, that is, with this request ID you can directly get to know which database server is the data stored in. What problem does this solve? It saves the time. It gives a direct address or routing. So that is why hash functions are used. And as I told, with the key value mapping, it is easier and faster for lookup. Now, these are used for routing because we don't know on which database we should be sending our request to. That is why we use it for routing. And of course, it spreads the data evenly, and it provides a fixed range and a deterministic range. So that is really helpful. Now, again, there is again a problem with hashing alone. That is what happens when you scale the system. That is, you increase the number of databases. So here I have given an example of what happens when you add a server. So before there were only 3 databases. Now I have added the 4th one here. So what happens now? Let's say the request ID is still 1, 2, 3, 4, but now our logic changes. That is, hash of request ID by n, and here the n value is now 4. Now when we take the same input and we do the hash of 67211, we get 67211, and when we do the modulo, we are getting 3 as the output, which means that your new data should be now stored in the database 3 instead of 2. So this means that we should be moving the data of this request ID from database 2 to the database 3. Now this may sound simpler, but what is happening is this is a very slow process, because we are constantly moving data from one DB to another DB, and there are very high chances of inconsistencies and failures. So data must be moved from DB2 to DB3, and this slows down process, and over time this is really not feasible. So this is the problem which is being faced in hashing, and that is why we will be introducing consistent hashing, and we'll be understanding that how we can solve this problem of data moving and the slowness problem. So in hashing, there was this problem of data movement, and which made the system very slower. So to address that problem, we have this concept of consistent hashing. Now what happens in consistent hashing is we basically construct a ring, and it is composed of evenly distributed values. Now here I have taken the range of 0 to 100, but in real life it will be from 0 to 2 power 32, which is a part of integer range. So now what we basically do is we pass our database nodes through our existing hash function. Let's say our hash function gives the output as 0 for DB1, and similarly 25, 45, 70 for DB2, DB3, DB4. Now what we do is we place those nodes at their respective positions. So I've placed DB1 at 0 and DB2 at 25 and DB3 at 45 and DB4 at 70. Okay, so now let's say we get the input request, and the request ID is, let's say, 2. Now we pass this request ID to a hash function, and let's say we get the output of 16. Now we place this output in this hash ring, that is, it will come somewhere here. Okay, so now what is the next step? We then go in clockwise direction and try to find the next DB node which is nearest. So we find that the nearest DB node is DB2. So what happens is DB2 serves this request. Similarly, let's say the input is 12, and when we pass it through the hash function, it gives the output as 33. Now 33 somewhere lies here, and we go in clockwise direction, and we find that DB3 is the nearest, and therefore DB3 serves the request 33. So this is how consistent hashing works. Now how does this solve the problem of data movement? So let's say we introduce another database node, and we just place it at 37, okay, and we have DB5. Okay, Now DB5 is placed at 37th position, and now what happens? What happens is the 33 request was being initially handled by DB3, but now it should be handled by DB5, right? So what happens is we are only moving the data for this much part, and we exactly know where the data should be moved. Again, data movement is there, but it is minimal. Data moving is minimal, and it is easy for us to compute what data should be moved. We know that only this data should be moved, which will be handled by DB5. Okay, so this actually increases the speed, and it reduces the load, and it helps us to change the places of data efficiently. So this is how consistent hashing helps us in data movement. And now there comes a problem of, let's say we remove a specific database node. Let's say we just remove database 2 and database 5, right? Now whatever the requests 16 and 33 which were being handled by 2 and 5 now will be handled by database 3 alone. So this is like you are giving the database 3 twice the load which was it was initially handling, right? This represents a skewed distribution of databases. This is not healthy because database 3 gets increased load. That is when we introduce the concept of virtual nodes. Now, what are these virtual nodes? Virtual nodes are simply pointers. So let's say we have database 4. Now database 4 will have a virtual node present somewhere here. Okay. And let's say similarly we'll have database 3 somewhere here, and database 1 somewhere here. Now what happens is the request coming from 16 now not going to database 3, but it goes to this pointer DB4 which stores it at the DB4th position, right? So we are basically introducing pointers throughout the distribution so that one server or one database node doesn't get so much of load. Now this solves the problem of redistribution, and it helps in skewed representation. So this is how virtual nodes helps in distributed systems with skewed representations. So this is the overall concept of consistent hashing and why hashing is required. Thank you.